acts on a body, the body tends to undergo some deformation. Due to cohesion between the molecules, the body resists deformation. That you know, okay? This resistance by which material of the body opposes the deformation is known as strength of material. जो resistance है उसी को हम strength of material कहते हैं. This resistance by which the material opposes the deformation. Okay, so that resistance is called strength of material. That resistance is basically defines the strength of material. How the material strength is defined by this. Within a certain limit, an elastic limit, the resistance offered by the material is proportional to the deformation brought out on the material by the external force. Also, within this limit, the resistance is equal to the external force. So, in the elastic stage, the resistance is directly proportional to the external force. Okay, but beyond the elastic limit, the resistance is like less than the applied load. Whichever is the load is, whatever is the load is, it should be more than the resistance. Okay, then the deformation starts happening till the failure takes place. Okay, until the failure takes place. Now, within the elastic limit, the resistance offers resisting force is equals to applied load. So, within the elastic limit, resisting force equals the applied load. This resisting force per unit area is called stress or intensity of stress. So, resisting force upon the area is called stress or intensity of stress. Okay, that is cleared. Now, stress we are going to discuss in deep. The force of resistance per unit area offered by a body against deformation is known as stress. The external force acting on the body is called load or force. The load is applied on the body while the stress is induced in the material of the body. Okay, load is applied but stress is induced in the material of the body. Okay, a loaded member remains in equilibrium when the resistance offered by the member against the deformation and the applied load are equal. Guys, sorry for the background noise. Okay, I'll try to minimize the noise. Mathematically, stress is written as sigma is equal to P by A. So, sigma here is stress, also called as intensity of the stress. P is equal to the external force or the load. A is equal to the cross-sectional area. Okay, units of stress क्या होते हैं? The unit of stress depends upon the unit of load and the unit of the area. In MKS unit, the force is expressed in kgf and area in the meter square. Hence, unit of stress becomes as kgf per meter square. If the area is expressed in centimeter square, the stress is expressed as kgf per meter square. In the SI unit, the force is expressed in newtons and area is expressed as meter square. Okay, hence unit of stress becomes as Newton per meter square. The area is also expressed in millimeter square. Okay, so this thing is very much clear. 1 Newton per meter square is equal to 1 Newton upon 100 centimeter square. So it is 1 Newton per 10 to the power 4 centimeter square, which can be written as 10 to the power minus 4 Newton per centimeter square, or we can write it as 10 to the power minus 6 Newton per mm square. So you can simply write it as 1 Newton per mm square is equal to 10 to the power 6 Newton per meter square, and you can also call it as 1 Newton per meter square is equal to 1 Pascal. That is clear. Now kilo is 10 to the power 3, mega is 10 to the power 6, giga is 10 to the power 9, tera is 10 to the power 12. That is cleared. Okay, milli is 10 to the power minus 3, micro is 10 to the power minus 6, nano is 10 to the power minus 9, pica is 10 to the power minus 12. All the negative things are written as in the small letters like this. Like milli is m small and micro is small in the small letters, and nano is also okay, and p is for pica. Now 1 Newton per meter square. So Newton is unit of force. Okay, so force is nothing, just kg. Okay, and acceleration is 1 meter per second square, so it can be written it as kg meter per second square. Okay, next is strain. Next strain we are going to discuss in another video. So please like, share and subscribe to my channel, and thank you so much for watching.